Hello and welcome to Explorer Classroom. My name is Gina Borgia and I'm so excited to have you join us today for our first event back after winter break. At National Geographic, we believe in the power of exploration, wonder, and storytelling to change the world for the better. This Explorer Classroom YouTube show connects students around the world with our National Geographic Explorers for short lessons and time for your questions. Today, our explorer is Dr. Baker Perry, a researcher who studies snow, ice, and glaciers. He is a professor at Appalachian State University, where he teaches about geography and climate change, and is also an accomplished mountain climber. He merged his skills of geography and climbing to join the National Geographic and Rolex Perpetual Planet Everest expedition in 2019, where he and his team installed the world's highest weather station. And in 2021, Baker co-led an expedition to install a weather station on the Tupungato volcano in Chile. Baker has led or co-led research expeditions in the tropical Andes and, along with local collaborators, has installed and maintained 6 meteorological stations above an elevation of 5,000 meters. He also writes about his research and shares what he has learned with people around the world. He's here today to give us a behind-the-scenes look at what goes into executing high-altitude expeditions and to explain what scientists can learn from weather stations on the world's highest mountains. I cannot wait to learn more about what these weather stations can tell us, but before we get into today's lesson, let's welcome all the friends joining us from around the world. We've got some shout-outs to give this morning. Hello to the Dawa Homeschool, Sharma, Genesis, X Venture, Don Tyson School of Innovation, Aquinas Montessori School, Center for Leadership and Learning, Copperfield School, Future Makers, Garfield Middle School, Golden, Hartfield Central School, Institution Marif Educational Complex, Kennedy, Masonville PS, Ramblewood Middle, Sayon, Santora Family, St. Mary, Surrey O'Dea Secondary. We're thrilled to have you all here. And with that, let's get this Explorer Classroom started. It's time to turn it over to our Explorer. Take it away, Baker.
Well, thank you, Gina, and welcome everyone. It's wonderful to be with you, and I'm excited to share a bit more about these high elevation weather stations. So I'm going to share my screen, and just bear with me just a minute. I go to full screen. I'm going to get rid of some of these things at the top. And I think we are now ready to go. So again, the title of this presentation is Why Install a Weather Station? And perhaps in parentheses, we could say on the top of a mountain or on the top of Tupungato volcano in Chile, which is what this photo is from right here. So let me tell you a little bit more about this. And on a personal level, my journey started at a very young age. I know you can't guess who I am in this classroom here from 3rd grade, but I actually spent part of my childhood in the Andes of Peru and Bolivia, and came to appreciate the importance of these high mountain environments, and especially the snow and ice that's stored on these mountains that serve as water towers and that sustain large cities such as La Paz, Bolivia, that you see right here, or smaller communities downstream from these mountains. And this is not only the case in Bolivia, but in Chile that we'll go to next, or in the Himalayas, where there are over 1 billion people that live downstream from these water towers. And we know that these high mountain regions are changing fast. They're warming faster than many other places around the world, and therefore glaciers are retreating, and the amount of snow and ice found up there is decreasing. And so National Geographic and other scientists have been very concerned about the world's supply of fresh water as a result of this mountain snow and ice disappearing. All right, so that is the context within which National Geographic and Rolex started this mountain initiative. And the first expedition was to Mount Everest in 2019. And the reason for this is that we just don't know a lot about what is happening up high. There are only 6 weather stations above 6,000 meters. This is just under 20,000 feet high. And before our expedition to Mount Everest, there were only 2 stations operating above 6,000 meters. And really, there's just a handful in the world, and we don't fully understand. We don't know enough about what's happening up at these highest elevations, even though this is where the bulk of the snow and ice is found in the Andes and the Himalayas. Now, below 3,000 meters, below about 9,600 feet, there are lots of weather stations. Okay, so why don't we have more up high? Well, they're just very hard to install. Number one, because there are no roads. It's pretty much dependent upon people carrying the equipment up there, doing the work, and then just being able to maintain and operate those over longer periods of time is a huge challenge. So logistically and from a physical standpoint, it's just very difficult to function and operate up at these extremely high elevations. So in 2019, as I said, we went to Everest, installed a station in the Sherpa community of Fortsey. We installed one at Base Camp. We installed one at Camp 2, and we installed the 2 highest in the world at the South Col and the balcony. And to get to the South Col, we had to climb up the Lhotse face, and we worked with this incredible Sherpa team that did an excellent job installing that South Col station that you see there. And then we moved up to the balcony, which is at 27,657 feet, and installed the highest weather station in the world. All right. So that was in 2019. And we've had just so many helpful scientific findings come out of this network, including related to just the intensity of the solar radiation, related to wind speeds. We're now improving the climbing forecasts for Everest. We know that melt may be occurring even up to the summit of Mount Everest. And so there are just lots of interesting and very relevant scientific findings that have already come out of the Everest weather stations. And so kind of as a result of the success on Everest, National Geographic decided to mount an expedition to Tupungato volcano here in Chile to also install a network of weather stations. And this was with our Chilean colleagues, Gino Casasa, Franco Buglio, Alejandro Espinosa, and many others. My colleague from Everest, Tom Matthews, who co-led the expedition with me. And we started walking at about 6,000 feet and had over 12 days went to the summit of Tupungato volcano. And this is where we installed a station just below the summit at just over 21,000 feet. And then our Chilean counterparts had previously installed 2 stations on nearby Tupungatito volcano, which I'll show pictures of here in a minute. But I think what this map on the left illustrates is just how close these mountains and the glaciers are to Santiago and the 7 million people in Santiago, Chile, that directly depend on the water resources coming down from these mountains. And again, there have not been any weather stations up above 8,000 feet in this region. And so really have not known what sorts of temperatures or wind speeds or precipitation have been occurring up there. And so this is why the expedition was very important. Here's a closer view of our ascent route. Again, we went right up the Colorado River, and while we were acclimatizing and adjusting to the altitude, we went up to the Tupungatito station, visited it, did some maintenance on it, and then came back down, had a base camp at Vega de los Flojos, and then worked our way up these steep routes all the way to the summit. This was our team. We had a great representation from the Chilean government. We had a team of guides. We had horsemen that were just phenomenal. We had some media team members with us, and we had some helicopter pilots that played a very important role, as you'll find out here as well. So here's the lowest station at Tupungato Bajo, and it's right next to the glacier. You can see there's a wind. There are two different wind sensors at slightly different elevations. There are two different temperature and relative humidity sensors here. There's solar radiation, both incoming and outgoing, and there's incoming and outgoing long wave radiation, the thermal. So this is the full energy balance. There's a snow depth sensor that we have here, and there are also temperature sensors in the ground that are measuring the soil temperature and tracking any changes to the permafrost that is present there. Same setup up high.
Climate change is incredibly important in high mountain areas around the world. Having observations from the highest elevations of the Andes here are critically important for proving our understanding of how climate is changing.
We've got quite a bit of wind up high on the upper mountain. Otherwise, yeah, I think everybody's doing very well.
We have a big data gap on the higher elevations where really we have no information about wind and so forth. The weather station will provide very valuable public data to decision makers in Chile and abroad.
A major challenge, of course, with this whole expedition occurred in the midst of a pandemic. And fortunately, with the testing and the quarantine that we implemented, we've not had any positive COVID cases on the expedition.
We're collecting water samples at this creek where we are actually feeding from water.
Got a really steep section that has our guides pretty concerned. So tomorrow, we're hopeful that the heli is going to be able to move some items above that tricky, steep section.
I am a documentary photographer and National Geographic Explorer, and my role here is to be the photographer in this expedition.
Really beautiful here.
We just climbed a very tough mountain, but we are really enjoying taking photos and walking. We are at 5,000 meters. We arrived yesterday, and tonight I didn't sleep very well, but today the sunrise was beautiful, so everything is worth it.
Everybody radio on. Hopefully batteries will last.
We've got winds of 6.9 meters per second on the summit. We're headed up to Tupungato to hopefully install this pumping station.
Good job.
We installed a station that's just over 6,500 meters, and this is a tremendous opportunity to really sample what's happening, in that part of the atmosphere.
I think we have the big responsibility of showing this to the younger generations and leaving a legacy of these stations with this kind of unique data.
Okay, so that's just a great short video overview of the expedition. And I think the key point, Gino, my co-leader, leaves at the end is that this is a legacy for you all, for younger generation, to understand what is happening and also to have more measurements from these high elevation sites. Now, we had a major challenge in a pandemic pulling this off. I'm not quite sure how we were able to do that and stay healthy and stay COVID free, but we had a team doctor on here. We had lots of COVID testing. We had social distancing. We had masks and everything like that. And so we were able to stay safe. The views from some of our higher camps were just absolutely astounding. No light pollution up here other than our headlamps, and the stars were absolutely amazing. And you could just see a long ways. Now, we did have some challenges. The deep snow presented major logistical challenges. We had hoped to get horses up higher, but you can see the horses were up to their necks in some of these snowfields trying to cross. And so that's why we had to rely a little bit more on the helicopter operations to move things higher, and we had to carry more loads ourselves. Once we were able to get a trail through some of these sections, it got a bit better, and we didn't sink as far down as the horses did with their hooves, and were able to make it through, but there were clearly some challenges going up. Now, this is the route that we took from high camp, which was 18,000 feet. And we went up through these snowfields and had to traverse through a rock band, which was a little tricky here, then up through this narrow gully, and then eventually began to top out. And we installed this just below the summit here of the Tupungato volcano. And a little bit about the weather station itself. There's a lot of wires, a lot of complicated programming, and just electronics that you see in this box. All of this was wired up and configured ahead of time. So when we showed up, all we had to do was basically plug things in with quick connects. We had to set up the tripod and put the instruments on and do all that. But we'd practiced this multiple times before, and that went very well. We did have a huge drill with us, so we could drill down and set these temperature sensors to measure the soil temperature and the permafrost, and also to install a grounding rod and to put anchors in where we didn't have solid rock. So this was a big load to carry that up. And here are two of my Chilean colleagues, Alejandra Espinosa on the right, a Chilean glaciologist who was just amazing to work with, Franco Buglio on the left. Again, both of these are accomplished climbers, top-notch scientists, and knew exactly what to do. And this is the station in the background. So similar to what we installed lower down, but the tripod is a little more specialized and lighter weight. And everything was designed to go on much more quickly with gloves and even mittens so that we could install it quickly, because the temperature was really cold. It was, I think, about 10 degrees that day. Even though the sun was out, temperature was cold and the wind was blowing. So there were some challenges there. And this is what the small celebration looked like after we successfully installed the station. Now, one thing, we had a really intense blizzard, and I started to talk over it, but just the sound effects are so important. And this was the day after we came down from the summit. And that was originally going to be our summit day, but we got some weather forecasts coming in saying, the winds might pick up and there might be some snow. So probably not a good day to go to the summit. There's no way we could have installed the station or even safely climbed up in that kind of weather. And we were pinned in our tents for over 8 hours. And this is like at the end of it when the sun was coming out and it wasn't snowing anymore, but it was just blowing. And so those were some of the challenges that we faced. Unfortunately, we were able to to alter our plan slightly to get that insulation in. Now, a little bit, just a few results to share. At the summit of Tupungato, the average temperature has been around -20 degrees Celsius. Okay, that's below 0 Fahrenheit. That's like -4 degrees Fahrenheit. So it's really cold up there. At the lower stations, it's a bit warmer, but still below freezing. And that's, you expect that with the amount of snow and ice and the glaciers that are found up there. It is very cold. It's also very windy up there. And we've experienced that firsthand, and we've seen that in the data as well. And the other little point that I wanted to share with you here is that the intensity of the solar radiation is just incredibly strong. And that means when there's bare ground, when there's rock and soil that's not covered by snow, the actual temperature of that surface is in some cases 30 degrees Celsius higher, okay, over 50 degrees Fahrenheit higher. And so on some days, we've measured temperatures from that weather station at the ground surface of over 60, sometimes as high as 70 degrees, even though the air temperatures are well below freezing, okay? And so that just shows you just how strong the sun is up there and heating those surfaces right on the ground. So the data from these stations is already helping the Chilean government and water managers understand the climate up at these extremely high elevations in this vulnerable water tower, and is going to continue to provide very helpful information for the scientific community and the Chilean government moving forward. And again, we plan to work with our Chilean partners to operate and maintain these weather stations as long as we can. And I do want to acknowledge of course, the critical support from National Geographic and our partners at Rolex in supporting and funding this Perpetual Planet initiative that has allowed us to go to Mount Everest and now to Tupungato volcano. So thank you all for tuning in, and I'm excited to answer your questions. And so I'm going to stop sharing and turn things back over to Gina.
Thank you so much for answering that question and all the others. And we're going to end with our last question that we like to ask our explorers on the show. Baker, what advice do you have for young explorers out there watching?
So my advice is to follow your curiosity, okay, and really ask questions and find something that you're really interested in, that you're excited about, and learn as much as you can about it. For me, when I was your age, I was fascinated by snow and ice. I went to the library and checked out books about Mount Everest, believe it or not, and also Antarctica, exploration history, and just weather in general. And so find something that really ignites a curiosity and passion inside you, and follow that and ask questions and be curious along your educational journey. So that is my advice for you at this age.
Thank you so much, Baker, for doing this very cool work and for joining us to share it. And thank you to the students for your fabulous questions. And thank you, teachers, who make cool stuff like this happen for your students. If this time of day works well for you, next week we'll be right back here live with National Geographic Explorer Karina Mafoon, an ecologist and canopy biologist who will take us into the fascinating world of fungus. And the following week, we'll learn about giant snail science from explorer Martina Panisi. Remember, you can register your student group for a shout out and a chance to be featured on screen at natgeoed.org/Explorer Classroom. It's good to be back, and we'll see you next time on Explorer Classroom.